So a lot of you have probably seen your favorite C# content creators creating videos that have benchmarks in them, and you've been wondering, how can I do that for myself? Well, I recently had someone comment on a video and asked, hey, how can I set up benchmarks like you've shown in here? And I figured I'd make this video to introduce you to BenchmarkDotNet and get you set up so that you can do it for yourself. So let's jump over to Visual Studio. Alright, so I'm here in Visual Studio and I've just created this new project to demo to you guys. So I'm going to go ahead and right click on the project because BenchmarkDotNet is a NuGet package, and I'll go to Manage NuGet Packages, and from there on the Browse tab, I'm going to search BenchmarkDotNet, spelt out .net, not with a dot. And you can see this package right here at the top. Currently has 19 million downloads. I'm going to be installing version 0.13.5. If you're watching this video at a later date, this version and these download numbers might be different, but this is the logo you want to look for, and you can see the project URL here as well. So I'm just going to press install, and then I'm going to press OK for this dialog that pops up, and then I accept for this other one that follows. And just like that, we now have the NuGet package installed. So I'll go ahead and close this package manager and go back to program.cs where we can get started. Alright, so to get started with BenchmarkDotNet, once we have the NuGet package, there's a couple things that we need to be able to do. One is going to be actually defining the benchmarks that we want to create, and then the second part is actually being able to select which ones we'd like to run. So just to start us off, I'm going to paste in the code here that is a benchmark switcher. This is built right into BenchmarkDotNet, and it's pretty awesome. There's a couple of different options that we can look at here, but I'm going to be using this .from assembly method that we have here, and then I'll be saying that we want to get the current assembly. So there's different ways that you can get the current assembly. You could do something like assembly.get executing assembly as well, but if you wanted to be able to select from different plugins or something more advanced, you could always change this up if you have your benchmarks located somewhere else. The final part that we'll tack onto this is the .run. It does take in the command line arguments when you're not using top level statements. That's just args. And if you are using top level statements and you have a main method, you also have args that can get passed into that main method as well. So I'm going to go ahead and press run on this. And of course, we don't have any benchmarks. So just to show you what it looks like, we see that this outputs no benchmarks to choose from. Make sure you provided public non-sealed non-static types with public benchmark methods on them. So that's actually a nice little hint for us as we're going through. So we're going to look at how we can actually create those benchmarks. But once we do that the proper way, again, public non-sealed non-static types, and then public methods that have this benchmark attribute on them, those are the requirements. Once we've provided those, we'll actually be able to see them listed out here in the selector, and then we can pick one and run it. Alright, so let's go ahead and actually create our benchmark class. So it needs to be a public class that is not static and not sealed, and that's because something about how the benchmark runner actually works is that it's going to create an instance of this, and it actually needs to be able to inherit from it. I'm not entirely sure how it works behind the scenes, but my understanding is that if you made this sealed and you actually try to force it to run, it will tell you that it's unable to do so because of something like that. And if you see, my autocomplete is actually suggesting exactly what we would want to do to be able to create a benchmark method, and like the output of that console said, we need something just like this where we have a benchmark attribute, and we just need the proper using statement for that, which I'll add at the top now, and then a public void of our benchmark. So you can name this whatever you would like, and it just has to be public and have this attribute on top of it. So currently our benchmark won't do anything at all, but let's go ahead and run this again, and we can see if the selector actually shows us what we can pick. Alright, so you can see all of the green here. This is a good sign. It says available benchmark. It says number 0 here, our benchmarks, which is the class that we created. So we can press 0 and it will go run this for us. However, it actually prints out an error for us because we are running this in debug mode and we need to be able to run it in release. There are some options you can use to override this, but again, if you're trying to do actual benchmarking, you do want to be using a release build, and you actually do not want the debugger attached to the process either. So instead of me pressing F5 to go run this or pressing the play button at the top, I'm just going to show you that I can right click on the project itself and I can go to the debug menu and then I can say start without debugging. Now, the other thing that I need to do though is switch this debug in the top left here over to release. So let's go ahead and do that. Then I'll right click again. I will go to the debug menu and then start without debugging. Now I'll select benchmark 0, which is the only benchmark that we have, press enter, and it will go run them for us. All right, now this benchmark's not going to be very exciting because we don't actually do anything inside of our method, but we can see the output here where it says the method name, and then the mean, and then the error from it. So we're going to look at a couple of other things and actually change the content of our benchmarks so that we can see some actual useful information. If you've been following along in Visual Studio and trying to do this at the same time that you're watching it, you might have tried to run this exact code and said, hey Nick, that took way too long for something that actually didn't do anything. So I've edited the video, of course, just to show you the output, but without any attributes on our class here called our benchmarks, it actually tried to go do a lot of warm up and actually go do a bunch of iterations to go run this benchmark. It actually took way longer than I would have wanted it to for something that doesn't actually do anything. So something that you can consider is these attributes called short run job, and there's also medium run job. And you can decide what kind of job that you want to go run, but by picking short run job, it's actually going to do a lot less work. And one might argue that if your benchmarks are going to be something that you want to publish and have other users look at the data, you probably want to spend a little bit more time running longer benchmarks so that you get more accurate data. But for almost everything I'm doing and just exploring, short run job does the trick for me. So let's actually look at the code inside of our benchmark, and of course right now it's not actually doing anything at all, so let's make it a little bit more interesting. What would happen if we wanted to go sort the items in a list? Well, we could go do something like list of ints and then make a new list here, and then we could go fill this list with a bunch of stuff. And thank you autocomplete, let's go do that. We'll add a bunch of things into this, and then we can say list.sort. Now, if we wanted to go benchmark the sort method here in particular, something interesting to note is that this benchmark is actually technically going to be testing all of this. So if you want to just know how long the sort was taking and maybe some of the memory implications, then you're not going to want to have this inside of the benchmark method itself. So we can go look at how to improve that. And because I mentioned memory as well, something else that we can do is actually put another attribute on here called memory diagnoser. And when we do this, in the output that we'll see when we do go to run this, we'll actually see some columns related to memory allocations. So just a quick pause to see where we're at. We do have our public, non-static, non-sealed class called our benchmarks. We have one benchmark method. We have it marked as a short run job so that it doesn't take as long to benchmark. And we have this memory diagnoser attribute on it so that we can see some memory information. Now, if we're interested in just profiling this sort method, well, we're going to be having to move this to a different location so that it's not included in the benchmark process itself. So let's go ahead and cut that out, and we can go explore another spot that we can put this. So something that we're able to do in BenchmarkDotNet is create a method, and I don't think it actually matters what you name it as long as you have this global setup attribute on it. What we can do in here is actually paste in the code that we were interested in, but the thing that we have to be considering now is that we're in different scopes for where our variable is declared. So we actually need to go move this to a field, and now you can see that this field is shared between this setup method and this benchmark method. I personally underscore all my fields so that they're separate and they stand out, so that's my naming convention that I use. So I'm just going to go ahead and do that. And then the other thing that you'll notice is just because I have some of these options turned on in my project, it's suggesting that this list object is actually potentially going to be null, and we might want to be concerned about where this is used. Just to make these warnings go away, I will mark this as a nullable list, and then I'm going to say that when we go to run our benchmark, I'll put this bang operator here because I am confident that this will not be null when we go to run the benchmark. And that's, of course, because this setup method will get run before this benchmark. And just to elaborate a little bit further about what global setup does, this is going to be something that we mark this method with, and this method will end up running before all of the benchmark methods that we have. So in our current example, we only have one, but if we had other benchmarks that were added in here, let's see if autocomplete works some magic. There we go. So if we had these two benchmarks, then this global setup will run once before both of these benchmarks get run. And that way you can set up your data only one time, and that way you're not having some extra overhead, even though it's outside of your benchmark, but you don't have this extra overhead of like setting things up per benchmark. For our purposes, we're only going to be looking at this one benchmark method, but like I just illustrated, you can have multiple. So what we want to look at now is if we go back to this global setup, we do have this 1000 number that was put in by the autocomplete. Thanks, Copilot. I'm not exactly sure why it picked 1000, but if we were interested in benchmarking things, we might want to pick particular ranges that we're interested in. And actually, there is something in BenchmarkDotNet that makes this very easy for us, and I'm just going to paste it on my clipboard here. So we have this public int list size, so I have a public field here, and then I have this params attribute, and what we're able to do with that is actually specify the different values that we would like to have for our benchmarks. So in this particular case, I've just put in 4 different variations. So we have 1,000, 10,000, 100,000, and 1,000,000. And then what we want to do from there is actually use this in our setup method, and we can use list size right here. So to actually explain what's going on when this happens, we need to think about how this global setup works and how the params work. So you can have different params, not just this one list size, and you want to think about BenchmarkDotNet actually creating a matrix of the different combinations of params that you can work with. In our particular example, our matrix is only one-dimensional because we only have this one param. What will actually happen is that per our one benchmark that we have here, our global setup will run once before this benchmark, and it will use the first param. And then once that's complete, the global setup will run one more time, and it will use the second variation, and then it will use the third, and then the fourth. And again, if you had multiple params, it will actually do a combination, creating a matrix of all of the possible combinations for your parameters. Now that we have the basis for our benchmark set up, let's go ahead and actually run this. So remember that we want to keep it in release, and then I'm going to run this without debugging. So I will go to this context menu, debug, and then start without debugging. All right, then we get our selection. So I'll press 0 and enter, and then I will edit the video and we can look at the output. All right, now that the benchmarks have completed, we can actually go look at the output table. This will look a little bit different than we saw earlier because if you recall, I did get us to include that memory diagnosis attribute. So we're going to see that we have this allocated column now as well, and this shows us the memory allocations. So our benchmarks are actually listed out here, and even though we have this one method, as we discussed, we actually have 4 different variations because as we saw with the params attribute, we were able to specify 1,000, 10,000, 100,000, and 1,000,000 for the list size. If we go over to the mean column, we can see that for 1,000 elements, it took just under 3 microseconds to go run this. When we went up an order of magnitude for the list size, so that's now 10,000 elements, we went up to 43 microseconds, and then an order of magnitude up again, we're at 511 microseconds, and then one more order of magnitude up to 1,000,000 for the list size, we are now at 6,108 microseconds. Interestingly, the allocated column really didn't use much memory at all, and even for the larger list sizes, we only had 1 byte and 5 bytes. And do recall that because we initialize the lists in the global setup, we are not seeing the allocation costs for the size of the list because that's done outside of the benchmark itself. And that's just a quick crash course with BenchmarkDotNet, and just a quick recap, we were able to look at how we needed to define the class, so it needed to be public, not static, and not sealed. And then we actually had to label the public benchmarks inside of that class with a benchmark attribute. We also discussed the job switcher that we had at the beginning of the program, and that lets us actually switch between the different benchmarks. And then we looked at the output, and we could talk about the mean column. We could see that we had the benchmark method name and the different parameters, as well as the allocated column that we got by having that other attribute on the top of our class. Finally, if your benchmarks were taking a little bit too long for your own patience, we did look at the short run job attribute, and you can play around with that for your own purposes. So hopefully you found this helpful. Thanks so much for watching, and we'll see you next time.